Okay, so I am going to present my blended course idea, which is going to involve 6th grade, 7th grade, and 8th grade science for weather and climate. So my target population will be middle school students, any grades between 6th, 7th, and 8th. And it's going to target small group work. Lots of what we're going to create curriculum-wise in this blended unit will deal with small group work. Whether the students are learning remotely or learning in class, they will have opportunities to collaborate with their peers. The first part that you need to consider when designing curriculum is your overall NGSS standards or your objectives. Now, NGSS standards is specific to science standards, but whether you're doing science or math or English, you will need to look at the state standards and then design objectives based on those state standards. So there's 3 NGSS standards that will align with this unit. The first one is to collect data to provide evidence for how the motions and complex interactions of air masses result in changes in weather conditions. Develop and use a model to describe how unequal heating and rotation of Earth causes patterns of atmospheric and oceanic circulation that determine regional climates. And ask questions to clarify evidence of the factors that have caused the rise in global temperatures over the past century. So, a brief overview of the content that I will cover in this blended course is the different layers of the atmosphere. Before students can understand weather and the circulation of weather, they have to first understand the different layers of the atmosphere. So we will include, there'll be a nice graphing activity that has a technology foundation that it will include the 5 layers of the atmosphere. And then piggybacking off the atmosphere is the greenhouse effect. You will have to explain the different types of greenhouse gases that can be found, and we will conduct a lab that has a representation of how the greenhouse effect occurs to keep our planet warm. And we'll talk about how we as humans impact the warmth of the planet and how we can change that and how we need to monitor the rising global temperatures for our own well-being. Then we're going to go into weather forecasting, talk about the 8 elements of weather forecasting. We're going to specifically zone in on station models and surface weather maps, which are common tools that you will see when watching the weather. That's your real-world connection. You need to understand how to read the weather maps that you will see on the news so that you can dress accordingly and different things and prepare for your day in that manner. Weather instruments are another thing we will discuss, how different instruments collect different information and data, and we'll talk about how technology plays a huge role in helping scientists collect this data and interpreting it quickly so that they can push out the information to the people. And then we can gauge what we're going to do and what we're going to wear based on this information. We're going to talk about the elements of weather, which is humidity, visibility, air pressure, precipitation, wind, and temperature. We'll talk about the climate and the climate zones. There's 3 climate zones: polar, tropical, and temperate. And finally, the influences of weather. We're going to talk about how the water cycle plays into it, how air masses and fronts play into it, the pressure systems, the global wind patterns, the jet streams, and the ocean currents all will influence the weather that we experience. All right, the learning theory that will guide this entire course is Constructivism from Jean Piaget. Constructivism is the idea of learning through experiences, which aligns very nicely with science, particularly science labs, which use different things to represent how phenomenon work. Special emphasis on the idea of authentic learning, and there are 4 things that make sure that this learning theory is appropriate for this blended course, which is the inclusion of cooperative learning, the inclusion of experimentation or labs, open-ended problems. Lots of science phenomena start with open-ended problems that the students have to hypothesize on how to solve. And then finally, your real-world application of how it matters to what's happening in real time. And then you have Constructivism is a learning theory that is actively constructed in the mind of the learners out of their experiences in the world. So the idea that they're going to learn through what they do. They also discovered that the learning environment will impact the quality of the students' learning. And they break down 4 categories of constructivism, which is attitude, concepts, skills, and knowledge. Now, attitude is where you're going to take into account the kids' opinions and their willingness to learn the content that you're delivering. Concepts, skills, and knowledge are going to discuss a child's ability to develop, retain, and apply the information that's given in instruction to other situations besides the one that's given in class. Their ability to take that situation and apply it to a new situation, and that idea of problem solving, which is a tough skill for students. Strengths versus weaknesses of this learning theory with the inclusion of technology. The constructivist theory enables technology even if there's limited devices. So the idea that collaboration is key, you don't have to have one-to-one devices in order to utilize technology with the constructivism learning theory. The constructivism learning theory is going to emphasize the importance of collaboration, so students may share devices. Weather is easily relatable and connects to real-world application. A huge part of constructivism is the idea of it applying to the real world and students having the ability to connect what they already know, their prior knowledge, to what they're learning, into what they will experience in the real world. Technology plays a huge role in weather because weather instruments rely heavily on the utilization of technology to quickly and accurately collect data and then to push out that data to the general public. Constructivism learning theory emphasizes students learn through their own experiences, and those labs will provide those experiences, whether those labs are virtual labs that they conduct via video, or they are hands-on labs they conduct in the classroom. That's going to get that experience of seeing whatever the phenomenon is. Technology enables students to experience the phenomenons that otherwise would not be possible due to resource availability, safety concerns, or costs. Technology plays a huge role in that, in helping provide alternatives to experience phenomenon, even if it can't be in a lab form. Virtual labs are a great example of this, whether that be they virtually manipulate or they watch a video of a lab. Either which way, they're going to get that experience that they would not have otherwise gotten. Some weaknesses include experiencing the phenomenon firsthand often eliminates the need for technology incorporation. When you utilize in-person labs, sometimes the need for technology isn't there. So it can be a struggle to incorporate technology into those lessons. Oftentimes, labs and other project-based learning implements a lack of structure in the classroom, which may hinder some students' learning abilities. Constructivism does kind of promote a lack of structure in the classroom, allowing the curriculum to go in a way that the students lead it. And it can be hard to pace that way, which is our next one. You're supposed to individualize the learning for the specific student. So in a middle school setting, can be very difficult to try to keep all students high, medium, and low on the same pace and on the same track. And then finally, the idea of abstract thinking or problem solving can leave students very frustrated. I've seen it firsthand, them to shut down and not want to do it if it seems too tough. That's why it's important that we build up those problem solving skills early on so they can utilize those skills and apply it to new situations. All right, some digital technologies that we will utilize in this blended course is Google Draw, one of the easiest and best digital tools, in my opinion, that many teachers don't already know about. I use Google Draw primarily for students to create and label diagrams and to create models. Many NGSS standards start with the term develop a model. So in order to meet that need, especially this year with COVID going on, I a lot of times have them create a digital diagram or model of a specific content area or phenomenon to demonstrate their understanding, whether that be as an assessment or as part of the lesson that we do together. It just kind of varies on what specific content and lesson we're working on. Google Slides are great. Google Slides can come in many different ways. You can have students create the slides, which is going to practice them collecting and researching the information on their own and picking out what's most important. Or you can also use interactive slides where you create a slide and the students have to go on and watch videos and answer questions and interact and move things on the slide to demonstrate their understanding. Could be a great assessment tool as well. Google Docs, simple, everybody uses it, but what's really cool about Google Docs is you can actually import a Google drawing into the Google Doc. So a lot of times I will import a Google drawing into the Google Doc so that I can ask all the questions I want to ask on the Google Doc, and then they have the drawing at the end where they just have to open it up, arrange the diagram or create their diagram, and then save it, and it saves right there on the Google Doc. Really easy to make tables for collection of data on Google Docs as well. That's what I do for many of my labs. Also, Google Docs allows you to collaborate very easily by sharing the doc. You can comment back and forth to each other, whether that's teacher to student or student to student, and you can edit the same document at the same time. Flipgrid, one of my favorite free resources ever. They get to create their own videos. They can watch each other's videos and comment on each other's videos, and you can see the comments and you can start discussion threads through those comments of the different videos. And you can create a video as a teacher to explain the directions of the Flipgrid, and then they watch the video of you explaining directions, and then they create their own video. Google Forms is a great resource because it has, especially for assessments, it's got many different types of questions. You're not going to see just multiple choice through the whole thing. There's open-ended, there's paragraph form, there's multiple choice, there's the check boxes one, there's a grid one where they have to match. It's like it's kind of like a fill in the blank except in a digital version, which is a great asset. It can also allow you to put in images and ask kiddos questions about the images that they see. So a great assessment tool. The nice thing about Google Forms is it will grade the multiple choice, checkbox, and linear grid questions. Now, as far as the open-ended responses, those are something that will have to be manually graded by the educator, but it is nice for them to be able to grade just those easier, simpler questions. And you want to have a variation of questions. You don't want to have all open-ended questions because that would be extremely exhausting for kiddos. So you want to have a variation. Have some open-ended, have some multiple choice, have some check boxes, have some images, and so on and so forth. YouTube and iMovie. I use iMovie to make this video actually, as well as to publish it to YouTube. It's a great way to enable students to watch my virtual labs or to create their own videos and to watch other labs that have been done previously. Canva, great graphic design site, allows students again to create visual representations, works very hand in hand with Google Draw. The difference being Canva has a lot more graphic design options, font-wise, elements, pictures, backgrounds, and such. But it's a little bit more difficult to use than Google Draw. And then finally, you have your flipped classroom approach. I've got numerous flipped classrooms, especially after this year. Every single one of my units has a flipped classroom with my lecture on it that the kids can go back and watch. Parents can rewatch. Anytime kids are struggling and parents ask me what to do, one of the best things I can give is a flipped classroom where they watch the video and take notes on their own. Then they come back and we do the lab or the practice or the activity in class where they can then take the information they learned from the video and apply it in class. And their homework is the notes part and the in-class part is the practice part or the experience part. Here would be my diagram that shows how these different digital tools fit into the constructivism theory. You got Google Slides, you got YouTube, and I made sure to color code it so you can see how they overlap. Many of these digital tools go in different categories. I identified the major categories of constructivism, which is cooperative learning, experimentation, student-centered project-based activities, real-world application, and then problem solving. And they all have multiple tools that can be utilized to meet that specific portion of the idea of constructivism. So it shows a really nice visual representation of how these tools can be used in many different ways. All right, and my summary. 21st century learning is authentic, collaborative learning with the integration of technology. In order to efficiently utilize digital tools, the digital tools need to align to a learning theory that aligns to the objective or goals. The first step is to identify the objective of the lesson. Often, utilizing state standards can help outline those key learning objectives for students. Once a clear goal is established, the educator needs to seek out which learning theories best align to their curriculum. Learning theories are an essential component of curriculum design and can help establish which resources and tools are appropriate for the given content. According to American College Education, learning theories can help identify the relevant technology and how best to apply it. Not only do learning theories help align curriculum to appropriate technological tools, but it also ensures the teacher is utilizing best teaching practices. 21st century learning challenges educators to consider real-world application, hands-on experiences, student-centered activities, student interest, and technology integration. Learning theories can help create a foundation in which to design a course or curriculum around. And last but not least, I have my references that I used to make this video. Hope you enjoyed the video, and I will see you next time.